Okay, so we continue our discussion about the structure of a typical C++ program, and is as we have already seen, the execution of the program always starts with the function called main, which has integer as return type, and it does not take any argument in them. So this is also known as the master function, and it is a function because that empty parenthesis that indicates the argument, right? You can actually have arguments that can be passed on. So if you have arguments, then that will go in those pair of empty parentheses. So those pair of parentheses in between that. So every function will have some arguments that it needs to work, and then it will have some return type. Some functions may not have any return type at all. So, but it will return control to the operating system or whatever function it calls. So, though that return type has a special name that is called void. Void actually, as you can probably infer, it just means nothing. So it's not a it just says the function returns nothing to the calling function. I mean, as by way of that return statement, right? So function main master function should be of integer return type for the operating system to receive the exit signal. So you can use this as a convention to indicate what status of the program was when the program returned control. So was it completed normally? Was the execution normal, or some other uh, unexpected conditions occurred which led to non-normal or abnormal exit of the program. Body of the program, that's the complete set of executable statements. They should all be included within matching pair of braces. So you will open one brace and then close it, and in between those matching pair of braces, you will find the complete body of the program. And each statement should terminate with a semicolon. That one executable statement should end with a semicolon. Now your statement can be very very long. It may not fit into 80 column that you would not that you normally have as a screen width, right? Editor width is normally 80 column width. So your statement, when as you will type, it may not actually fit in those 80 column space available in one line. So there are continuation marks. So the line can continue, executable statement can continue over multiple lines. We will continue come to that continuation marks. But the end of that executable statement is indicated by semicolon. So up to that semicolon, this entire sequence of characters is interpreted as one executable statement. Now we can have a couple of executable statements enclosed within matching pair of braces, right? And this entire unit between these matching pair of braces is known as a compound statement. So this will be treated for all practical purposes as a single statement, right? Once I enclose it in, it's like wrapping up a couple of books, right? Like your backpack. So there are several notebooks. So I carry that as one unit wherever I carry. So it's like that you can have several statements which are enclosed within a matching pair of braces. So that would be that would be interpreted as a single statement, and that is called a compound statement. Right? Compound statements are very useful and very particularly They are very often used when used with decision structure, when you need to take a call. I mean, if something happens, then do certain set of instructions. Else, if something else happens, then do certain set of instructions. So all these have to be clubbed together as one set of instructions which need to be executed, which need to be performed for a certain branching out of a decision structure, right? If this happens, then do this. If certain thing happens, then do this set of statements, right? So all these set of statements, they are enclosed as a in the pair of braces, and they are called as compound statements, so that that clause of decision applies to the entire set as one whole. Now, whenever you have any operation to perform, obviously you will need information. I mean, computer is essentially an information processing machine. So you have input information coming in, and you need to transform it, and then you need to produce the whatever is the desired information, desired output. Now all this requires some kind of storage. Where do you store the input information? You need to store the input information before you can process it, before you can begin processing it, right? So those, it is like the same thing as your classical algebra concept, variables, right? That was the first time you came across the concept of variables in algebra, right? So what is a variable? What do you mean by variable? Yes, it is a common name which can take any value, right? And that is what we need for writing a computer program, a general purpose program. We need a variable which can take any value as the need may be, right? So for one instance, it may take some input data. In other instance, another run, it may take some other input data, right? But it will be stored in the same variable, same name. You will be calling it by the same name for processing it in a designated fashion, right? So you need some storage to store data, and some storage to store the output before it can be displayed, or before it can be printed out, or whatever the output channel is, right? And this is done using what we call as variables, right? And they are essentially, I mean, we call it variable, but they are essentially pointing to is memory location in the storage. It can be either in random access memory, or it can be in the hard disk, or wherever, right? So it is essentially a storage space, and that name identifier which designates that variable, let's say x. X is the most common variable that we all recognize, right? So I call some variable x. Now on a computer, that x may be referring to some memory location address in the computer, right? Starting location, starting point, first uh, cell of that memory, right? Because it will depend how much memory, how much of byte, or how many bits would be used. That would depend on what type of variable I am defining. Integer is a different length, real or float is a different length of variable, double is a different length of variable, right? So this name of the identifier only points to the beginning of that cell, that this variable, content of this variable starts from this memory location, and it will end up to as many bits as required depending on the kind of variable it has been declared, right? So that way it becomes fully defined. So we need identifiers. Now variable is fine. I mean, the computer is completely full of, I mean, storage. You all have all this disk of terabytes is all available to store, but in order to access them in a logical way, I need to call them by certain names, which can be interpreted or understood by humans, right? So just as we call each other by our individual names, and that's what becomes our identifier, right? We call those memory locations also as some name, and that is what we call as identifiers, right? So we need identifiers to distinguish one memory location from the other memory locations, so that there is no confusion about which data we need to operate on and how that data needs to be processed. So what are the rules? There are certain rules of naming. So a valid identifier is a sequence of alphabets, numerals, or underscore characters, right? It should always begin with an alphabet. It should never begin with a numeral. It can begin with a underscore, but that is to be avoided, because no sane human being would begin a name with an underscore, right? That doesn't come naturally to us, and that is the reason why certain variables which are used for uh, operating system or system level information processing, those variables are intentionally named with underscore. They start with underscore. So that is a way to avoid any accidental conflict between names. So if I write a program, it's a highly unlikely that I would use an identifier which would begin with an underscore. So it's a convention. By convention, we use underscore only for uh, system level, operating system level variables that we need, right? So for general normal user programs, underscore should not be the first character of identifier, right? So identifiers beginning with underscore are usually used for system specific keywords or external identifiers. So in no case, as I said, identifiers can begin with a digit. Identifiers have to be different from the set of reserved keywords. There are certain keywords which are reserved. They have special meaning. For example, type declaration, int, it's a int. So int has a specific meaning to the compiler and language. I cannot use any variable, any identifier as int, right? Similarly, float, double, car, right? These are all reserved keywords. They cannot be used as identifiers, right? So there are certain set of reserved keywords. So they should not be used as identifiers. In fact, the compiler will complain if you use those as identifiers, and it will not allow you to proceed until you change it, right? And C, C++, both of these, as with most of the modern programming languages, they are case sensitive. Case sensitive means they differentiate between uppercase and lowercase of alphabets. So all these three that you see here, black, 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 three variations, just I cooked up something. They are all treated as three different identifiers. And any combination, I can have a combination, any combination of lowercase, uppercase, and it would be a different identifier again, right? And that brings us to a very uh, again useful convention, although it is not dictated by the compiler or the language standard, but that is a programming convention, programming style. Everybody evolves his or her own programming style over a period of time, and there are some good practices. So the good practices are, okay, where is it? Generally, uh, constants. If I define some constant, those constants are generally defined by using uppercase alphabets. So capital B, L, A, C, K, that would be a constant. If I need to define a constant whose value doesn't change, I don't intend to change its value throughout the program. So just by visual, if I look at any identifier and that looks as I mean it all capital, and if I am adopting that convention, then I know that this is a constant. I don't need to uh, worry about this changing its values or anything. First alphabet capital uppercase, remaining alphabets lowercase. These identifiers are generally used for global identifiers which have global scope. Global scope means they are visible all through the program, every point of the program, every function, everywhere. As long as the program runs, those identifiers are defined and accessible, right? All lowercase are generally limited in scope. They are local variables. They would be defined by the scope within which they are defined. We'll come to this, the concept of scope of identifiers in a little while after we discuss about different data types. Let's look at what are the different data types and what is the size that they need to store the data. So variables are stored in computer storage space, and the name identifier that we use to name these variables, they point to the first beginning cell of the data on that computer, wherever that storage is. Computer needs to be told about the type of data stored in that variable, because that is what will define from this point onwards how long, how many bits it needs to read to interpret that data, right? So that depends on what kind of data it is, and every different types of different types of standard data, they would have their own predefined size, right? So fundamental data types, these are the data types that are defined in the standard C++ standard. Character or small integer, that is 1 byte long. Wide character, I didn't get it. WIDE, byte. Byte is another unit. 1 byte is equal to 8 bits, right? So that sequence of 8 bits is referred to as 1 byte, right? It's like saying 100 paisa is equal to 1 rupee, right? So 1 byte is the basic building block in which we count the memory. It becomes easier. Bit is the smallest unit, right? But nothing much happens in a bit. It has only two states, either 0 or 1, right? So not much information is carried by single bit. You need at least 1 byte to carry anything meaningful, right? So 1 byte is actually referring to a sequence of 8 number of bits. And character is a character, car is a character variable. It is also interpreted as short integer, and that its length is 1 byte, 8 bits. How is it integer? That is because of what we have as ASCII coding, right? American Standard Code for Information Interchange. So there are a sequence of integers which are mapped to different keyboards, different characters on your keyboard, right? So they are interchangeable. So you can use a character variable as a replacement for short integer that is only 1 byte long or 8 bits long, small integer, right? Short integer has at least 4 bytes, and integer or a long integer, it has at least length of at least 4 bytes. So short integer 2 bytes and long integer 4 bytes. Boolean, that's a logical variable. It has only two. Again, binary state. It's a I would rather call it as a indulgence, some kind of indulgence, because a single uh, value, I mean, it's like a true or false. So it only needs to flag 0 or 1, right? And that is also treated as 1 byte long. Then we have float, the basic workhorse for real number, computing with real numbers, and that is by IEEE 754 standard. It is defined as uh, 4 bytes long, so that is 32 bits total. Double is a double precision variable float type, I mean floating point variable number, and that is exactly 2 times the float, and that gives you 8 bytes long. Right? WCAR-T is the wide character type. So wide character type is just extending the width of character variable. So character variable, basic character variable identifier data type is 1 byte long. Wide character is 2 bytes long. That's all. So that's a standard data type that are available in C++. We can define variables, we can define identifiers of these basic data types, and then we can store information in those identifiers and start processing that information and also store the intermediate results and the final result. But you are not limited or you are not constrained by only these fundamental data types. C and C++ are very powerful and versatile programming languages which allow you to define your own data types which are based on combination of these. So those are composite data types or user defined data types, right? We'll come to that in a later portion of the course, but just to let you know that you are not constrained only by these fundamental data types. These are there defined by the standard, but you can define your own data types which will facilitate uh, arrangement of data, right? It's not that you cannot do any meaningful programming by using only these data types. We can do that. These are more than enough to solve any problem, but certain things are easier to read, easier to process, or easier to implement in some other form, and that's why that freedom. So before any identifier can be used in a program, it needs to be defined, it needs to be declared, because it needs to be declared that this identifier is of this type. Unless it is declared, there is no way for computer to interpret how it has to be interpreted. I mean, it only knows the beginning address of the cell. How many bits need to be read to interpret, or how that data in those bits, that sequence of bits is to be interpreted to identify the contents of that. That is not possible unless those identifiers are clearly declared, what type of identifier those are. So either it is a character type identifier or float or integer, so whatever it is, that needs to be defined before that identifier can be used in a code. The syntax to declare a variable or identifier is to specify the type of data and the name of the identifier, right? So I can define it as signed int I semicolon. That is one complete executable statement. This defines an identifier. This defines integer is 2 bytes long. So it identifies, is it 2 bytes long, 4 bytes long, whatever, integer, long integer, 4 bytes long. So 4 bytes space starting from the memory location pointed to by this identifier I. Those 32 bits would be interpreted by using 2's complement notation for signed integer to model to designate any integer between these uh, whatever is the smallest negative integer and the largest positive integer in that range, 32 bit that can be accommodated in that range, right? So integer by default is considered to be signed. So if you drop this declaration sign, no harm done. But if you want to use the complete range, 2 raised to the power 32, those many combinations for only one sign, one-sided, then you need to specifically define this integer variable as unsigned integer. Then it would be treated only as starting from 0 to whatever is the largest number, 2 raised to the power 32 minus 1. From 0 to 2 raised to the power 32 minus 1, that's the largest integer that it will be, right? So int unsigned int j, float x comma y. So I can define, the idea is I can define as many identifiers as required on the same statement, separated by commas, and then terminated by semicolon, right? And optionally you can initialize the identifiers with some reasonable values at the time of its declaration. So just as signed short, short is again a synonym for short integer type. Signed short I is equal to minus 7. So minus 7 is assigned to this variable I from this point onwards, right? After this statement, wherever I comes, unless I has been modified somewhere in between, it will contain this value minus 7. Otherwise, the contents are unknown. It depends on whatever is the bit pattern of 0 and 1, it will be interpreted according to that particular data format. So whatever the contents can be anything, random data. So assignment can be of two types. Either we can use this assignment operator, that is what is the C standard, or we can use this constructor model. This is called constructor assignment initialization. So the identifier followed by the value within the parenthesis. right? So this identifier is created and this value within parentheses is assigned to it. So both of these are valid assignment initialization. Similarly for float, I can define multiple data in the same line separated by comma. So minus 2.3 assigned to identifier x and 4.5 is assigned to this identifier y and followed by the semicolon that indicates the end of executable statement. So as I said, this assignment operator is the standard for C language. In C language standard, the assignment happens through this assignment operator. C++ allows both this assignment use of assignment operator as well as this constructor style uh, initialization. Again, I'm using this term constructor a little ahead of time. We will come across this term constructor again when we discuss object oriented programming, right? Till that point, just bear with me. These are two possible ways. Just I am trying to expose you to two different ways of assigning or initializing the variables. Now scope rules. As I said, there are different variables, different identifiers, they have different lifespans, right? So what are their lifespans and how that lifespan is determined? So that is defined by the where that identifier is declared, location, right? So look at this example program. These variables, they have been declared outside this function main. These three variables have been declared and initialized outside this function main, right? So these variables are visible throughout the code, everywhere. These are called global variables. Okay? So this is integer, int integer assigned initialized to 0, car character assigned a value character C, float score assigned a value 0.0. These are all global variables which will be accessible from every point in the code. Once you declare here, its value is available and it can be modified. That is more important. Being accessible is one point, but that variable, that content of that identifier being amenable to modification, that is a very, very important aspect, right? And therefore, global variables should be used very carefully and avoided as far as possible. It facilitates ease of programming, of course, if all variables are globally accessible, but it also facilitates you to shoot yourself in the foot. You may accidentally modify the contents of this variable, global variable, and its effects would be manifest at some other location, and you would be spending many nights worth of midnight oil trying to figure out what has gone wrong and where it has gone wrong. So declaration can be either in global scope or in local scope. Global identifiers can be accessed anywhere in the code. Local identifiers are accessible only within the block in which they have been declared. So in this case, let us now look at this function main. Master function opens with this opening brace. ends with this closing brace. So if this float x1 initialized to 0, 0.0 and boolean type test assigned to true, that is, these are all local variables, right? And then if test, so that is the decision, if test is true then do this, if test is false then do that, right? Now look at this is a compound statement. It again opens a pair brace here and closing brace here. So everything in between these matching pair of braces is referred to as a compound statement. It can be one statement or it can be multiple statements. They are all uh, part of the single compound statement which follows this branch of decision. If condition, if that condition is true, then do this. Now, if I within this matching pair of braces, if I declare any variable, that variable is not defined outside this pair of braces. So this integer I assigned to value 0, this is not visible here. Integer y1, that is, or float y1, that is, that I define here within these braces. If I try to print it, try to access it outside this uh, range where it was defined, you will find that it is not accessible. Identifier I and Y1 would not be recognized. Again, that is something that compiler itself will trigger. If you try to use an identifier outside its scope, the compiler itself will flag it as an error, right? And you will not actually come to the stage of running the code, executing the code. It will not compile at all, right? So if you pay attention, I have been using this convention that I mentioned. First alphabet capital identifies the global variables, and all lowercase, those identify the local variables. And all capitals, I typically use it for identifying constants, identifiers which are constants and they do not change during the program execution. So naming convention and programming style, this is what I use. This is the way I define identifiers whenever I write code. So all capitals, they are recommended to denote constants. First character capital is recommended for global variables. All lowercase is recommended for local variables, and indent in the code is strongly recommended to make the structure visible. What is an indent? If you write, if you have tried writing code using code blocks, you would notice that code is automatically indented. Whenever you start a new for loop or new if structure, next sentence would always be flushed little towards right, shifted towards right. That is indentation. So that visually it becomes clear which block this set of statements belong to, right? If you write, I mean, this has nothing to do with program standard or the program language, right? Program would compile just as fine if you do not indent your code at all. Start writing from the first column onwards, right? Nobody, the compiler would not complain, of course, but it is heavily taxing on human being to try and read and understand that kind of code. It becomes easier to read a code if it is properly indented and the structure is visible uh, visually. So 3 spaces is recommended as an indent length. So these are all the programming convention, recommended programming convention by Free Software Foundation, GNU, GNU standard for coding. So now we come to expressions. What do we mean by expression? I mean, we have discussed the identifiers which can store the information. Now that information needs to be processed. So that processing needs to be done using some kind of operation. So those operations, how we code those operations, those are what we call as expressions, right? So expression is a combination of operator, literal data values and identifiers that can be evaluated. So operator, as you all know, operator is something that takes on values and does some operation on those values. So just as addition is an operator, it takes two operands, right? X plus Y. So plus is a addition operator. It takes two operands, X and Y, and given two operands, two identifiers containing data in X and Y, it would add them together and produce the result in that can be stored in another identifier. So operator is a mechanism that takes data values and transforms them into a new data value. The examples are negation, change the sign, that is a unary operator, that is that only negation only takes one operand, so that is a unary operator, only one argument required. Multiplication, real division, integer division, remainder operator, addition operator, subtraction operator, all of those are binary operators, right? Division operator is overloaded. You We make use of the same sign slash forward slash to indicate division, but the behavior is different depending on what is the type of operator operands. If I am using it as a division for two integer values, its behavior is different, and if I use a division operator for, if any of the operator involves float or a double type of data, its behavior is different, right? What is the difference in behavior? In integer division, fractional part is discarded. In real division, we retain the fractional part. And if one argument is real and another argument is integer, integer is first promoted to appropriate real, float or double, whatever the other argument type is, and then real division is performed. And operators have default precedence order, and expressions are evaluated left to right. So it will start from the left and start evaluating from left to right. And precedence, do you recall precedence of operators? Class 3 arithmetic. BODMAS. For those from English medium, it's called BODMAS. For those from Hindi medium, there used to be a couplet. I still remember it. का करी के पुनि भाग कर फिर गुम लेहु सुजान का पाछे धन ऋण करो भिन्न रीति योजन. Right? So that's the precedence of operators. Right? Which operation happens first? That's it for today. will continue tomorrow.